As we continue our journey through the technologies that have influenced the FlexVertex Data Multiverse, it's now time to examine graph databases. First and foremost, graph databases have nothing to do with graph paper, nor are they based on graphics. Instead, it's easiest to think of a graph database as a collection of objects known as vertices that are linked to other vertices using something known as an edge. One of the beauties of graph databases, in contrast with many other NoSQL technologies, is that graph databases can automatically maintain relationships using these edges. In the absence of these relationships, it would be up to the developer to keep their database's referential integrity intact, and that's a recipe for problems. Let's examine some sample graph data in more detail. We'll begin a very simple example of graph data by using these 4 people who are a small part of a large social network. Each one that you see on the screen would count as an instance of a vertex. The gentlemen in this graph all have some knowledge of each other. We express this relationship via edges, which are labeled as has-friend. Notice that these edges may be one way, in other words, Groucho considers Harpo to be a friend, yet sadly Harpo doesn't reciprocate. Meanwhile, Margaret has no friends in this little section of the graph. Let's introduce another type of vertex, one dedicated to a particular flight. As it turns out, both Groucho and Harpo flew on this flight, so we've created one-way edges that depict this relationship as flew on. Now, let's imagine yet another type of vertex, one dedicated to hobbies. In this case, we've created an instance of a hobby vertex and called it skiing. Both Groucho and Margaret have an interest in skiing, even though they have no friendship relationship between them. By now you can probably envision the richness of a graph model and the edges that can link vertices. Suppose that a large financial services company is either maintaining this graph or has purchased access to it. Their goal is to present a special offer for this high-end credit card to people who either travel or have glamorous hobbies such as skiing. So, using the results of a simple to-write query, which we'll demonstrate in other videos, it's easy for the financial services vendor to identify the exact people that might be interested in such an offer. Earlier versions of graph databases did many things right, but there were some notable implementation gaps that have hurt adoption, which is one reason why these types of products have never reached their full potential. For example, they were largely originally meant for decision support applications, so transactions weren't usually available. In cases where data was actively written to them, it was also difficult to fully protect the integrity of the graph's information. And finally, and possibly most importantly, the query languages that developers needed to master to successfully navigate their graphs were horrendously user-unfriendly. It should come as no surprise that we learned from these omissions when we designed the FlexVertex Data Multiverse. We'll be discussing each of these improvements in other videos. Subscribing to this channel is a great way for you to keep increasing your FlexVertex knowledge.